Here's our homepage, obviously. Let's go to calendar. Okay, so this is tonight. I noticed a few of you still need to reply to other posts for the discussion. So if you have not replied to other people, please do so. I noticed a few of you need to do it. So don't forget to do that by the end of the night. So on Sunday, you'll have homework section 17 that will be due 11:59 Eastern Standard Time. And Tuesday, exam 3, test 3, and your partial credit pictures will be due. And I cannot give any extensions for that. So no extensions for the final exam. We're going to review for the final exam tonight, but that is the schedule. Okay. Go back here. Student view. Sorry for all the flipping. Okay. So I'll mention this now and I'll try to mention it later. So this is what's all due tonight. Module 7 is due tonight. Module 8 is really just homework section 17. There's no quiz at all. There's some videos for it. Homework section 17, and then the textbook solutions for section 17 are right there. I uploaded this as completely optional. You don't even have to open it if you don't want to. It's completely optional. What's not optional is exam 3. You definitely want to do that. I uploaded some practice tests. If you're the kind of student that wants even more material to study from, here's the place. Okay. So again, let's go back. So this is 100% optional. You don't even have to open this. There's nothing graded in here. It's just bonus material if you want it. But these are 3 paper exams that I've given before or that have been assigned before. So if you want that extra practice, there it is. There's 3 exams. And then the solutions to those exams are right here. They correspond, 3A would correspond with 3A. So that's just some extra study material. If you want to use it, you don't even have to look at it if you don't want to, but it's totally optional. Okay. But for those, I know somebody will ask me, somebody will want it. So it's there if you want it. So you'll have homework section 17, which we got to go over 17 in just a minute, but it's not super long. It's not a super long one. So that's the good thing. You have the practice exams if you want to look at them. You have the normal test review. You do have to take the test review. You have unlimited tries though. Academic honors policy, the actual exam 3, and then you will submit your partial credit scratch work. Okay. And it always really helps me if you number your problems on your scratch work. It's a lot easier to give you extra points when I know what goes with what problem. Okay. So that's the schedule. We still have to go over homework, or we still have to go over section 17. And then we're going to review for the final exam or exam 3. I'm going to use those terms interchangeably because I always think of it as a final exam. It is a final exam. It's comprehensive. It goes over the whole class. But a lot of times it's called exam 3. Sometimes it's called final exam. It's the same exam. Okay. Also, I have an announcement coming out. I need to check it for grammar mistakes, but I have a hint list for exam 3 of what to look over if you want to. Now, that's a lot of material. You have 3 practice exams, you have the official test review, which you have to take. And then here is a hint list for exam 3. That's about the most I could tell you. It's 29 questions. It's 180 minutes. It's the usual rules apply. We're going to use the lockdown browser. Yeah. Okay. Any questions about that? This announcement will go out at 9 tonight. I just need to check it for grammar mistakes and make sure that I'm making sense. Okay. So, good. No questions? Grace, did you have a question?
Oh, no, I'm sorry.
Okay, I didn't know. Okay, so I think I'm gonna get to the presentation. And what is the presentation? It's section 17. I based my examples very heavily on the homework, so that's a good thing. And then I'm gonna do a practice exam until we run out of time. I don't know how long it will take, but I'm gonna do an exam. I typed an exam in PowerPoint so we can go over that, okay? So I'll do homework questions at the end, but are there any questions about schedule, what the final exam consists of, anything like that? And project 2 is now graded. So if you have any questions about that, you can stay after class or you can come to the office hours or whatever, ask your questions about that. But overall, the projects went extremely well. So I was very pleased with them. So hopefully you will be pleased with the grade. Okay. Okay, so I'm gonna start the presentation. I'm gonna turn off my camera because it does seem to help with the bandwidth. Okay, let's go. So this is session 8. We're going to go over section 17 and the final exam review. What's due? Homework section 17. On Tuesday, October 12th, no extensions. The exam 3 review, I know it says test review, that's interchangeable, that's the same thing. The exam 3 itself and partial credit pictures. All due October 12th, 11:59 Eastern Standard Time. No extensions can be given. All right, let's go over section 17. So section 17 is going to look at margin of error. What this has to do with is, think of those like polls and surveys. Channel 5 News has done a poll and 32,000 people replied to this poll, and they all say that Math 123 is the best math class offered at Ivy Tech. Okay. So that's the kind of poll and surveys they're talking about. There's an inherent error in this. Okay. So the error that comes in is that we're extrapolating the idea that based on the respondents of the poll, we're going to try to extract that must be true for everyone, say in the United States or something like that. Okay. We have a survey, a certain amount of people say that they make this much money at their current job. Well, we're extrapolating that most people in the United States make that based off of the poll. Okay. So section 17 looks at error within surveys. With these problems, we'll read the results from the survey, then apply margin of error to the percentage. We're going to add and subtract a value. So the error comes in with how many people are asked in the poll. All right. There's a way to calculate that. Tonight, we're just going to see how you use that error and what we can extract from that. So finally, we write the sentence about these results. Okay. So fair polling. The population of the poll refers to the people or objects whose properties are of interest. So if we did, if we made a poll of Ivy Tech students, well, these are Ivy Tech students. Maybe we're extrapolating that these are all college students. That would be a population, or we're doing just Ivy Tech students. So that's what's talking about population. Sometimes you're dealing with countries, so that would be the same population, right? So that's what the population is. The sample set is just the people that responded to the survey, okay? They're not everybody. So if we have a survey with Ivy Tech students, not every Ivy Tech student actually responds. There's just a sample or a subset of those students. We're trying to extrapolate how all Ivy Tech students think about Math 123 or something, whatever the poll actually asks. But it's just a sample, it's just a subset, it's just a smaller group than the actual whole group, okay? And when taking a poll, it is important to ensure what the sample is not biased. So you don't want to make a poll inherently biased towards one result. Now, this is easier said than done. In fact, as we all know, when we're adults living in a real life, people extract whatever they want to make the results that they want to have. So we know in reality that that's not always followed. But ideally, you would make a poll or a survey that would be completely unbiased of the results. Often, this would be done by an independent. So you would want to do it not by, so, Ivy Tech making a survey of its own students, they might have a little bias of how that thing turns out. So if you have an independent, someone that's not affiliated with Ivy Tech that does the survey, that should keep some of the bias out of the poll. Okay. So margin of error. Now, margin of error is going to come with how big the sample is, how many people they actually asked. If they only ask one person, what do you think of Math 123? And then we assume, well, all Ivy Tech students must think that that's true. Well, that's 100% error. We can't determine it from just one person. So polls and surveys should report the margin of error because of the possible variation in responses from sample to sample. The range of values found by adding and subtracting the error is called the confidence interval. The confidence interval allows us to make statements about the entire population, not just those that were surveyed. To use the margin of error, we add and subtract the sample of the percentage reported. So we go sample percentage minus the margin of error, sample percentage plus the margin of error. Note, both values are in either decimal form or percent form before combining. All right, well, this is going to make sense when we get into an example, okay? A 2021 Gallup poll of 1,762 adults found that only 32% felt fully engaged with their mortgage provider. What is the sample size? And the margin of error for this data set is 2.4%. So they're just telling us what the margin of error is. We don't have to calculate it. They just told us that the error is 2.4%. What is the confidence interval using one decimal? Okay, so the question is, and this is very common for these type of questions, what is the sample size and what is the interval using this margin of error? That's the exact same thing you're going to see on your homework. First, what is the sample size? The sample size is how many people were polled or surveyed in this study. That would, in this problem, that would be 1,762. Okay, that's how many people were polled or surveyed. So that's the sample size. Now, the margin of error, they just told us that. They said it's 2.4%. They told us it's 2.4%. We need to find the confidence interval. How do you find this interval? You take the percentage that they gave us, 32%, and then you add and subtract that error. So by doing that, if I go 32%, which felt fully engaged by their mortgage provider, we could subtract 2.4%, so 29.6, or 32 plus 2.4 would be 34.4%. So because there is an inherent error in this, we're saying that from 29.6% to 34.4% feel fully engaged with their mortgage provider. Okay. So what do you actually do as the math student? You identify what the sample size is, you take the margin of error that they give you, and you add and subtract that to the percentage that they give you. Okay. So that's what we actually did. We just add and subtracted that 2.4%. So it gives us a range, it gives us that interval. Let's look at another example. A recent poll of 2002 Americans aged 18 and over, conducted in the May of 2020, found that 82% of the respondents strongly agree that kindergarten through 12th grade schools should teach critical thinking to children. First question is, what is the sample size? And then the second question, for this survey, the margin of error is measured to be 2.2%. What is the confidence interval? Answer with one decimal place. Okay, so first, what is the sample size? The sample size is how many people were surveyed or polled, right? How many people were surveyed in this study? 2002. That's how many people were surveyed. Okay, now for the margin of error, they give us 2.2%. Let's find the interval. So they said that 82% of the respondents strongly agree, but we know there's some kind of error. So we can add and subtract the margin of error. So we add and subtract 2.2%. I find the interval to be 79.8 to 84.2%. Okay. Okay, so hopefully it's clear what we're doing. All right, another example. If a survey of a movie shows that 51% of all people who like the movie enjoyed the official movie soundtrack too, if a total of 8,350 people were asked, find the following for the survey. What is the sample size? And if the margin of error for this survey is 1.1%, what is the confidence interval? Give it in one decimal place. So what is the sample size? That would be the 8,350 people that were asked. What is the confidence interval? Well, 51% of people who like the movie also like the soundtrack. So we just add and subtract 1.1%, and I get 49.9% to 52.1%. Okay. So hopefully it's clear what you're expected to do. You're finding the sample size And once they give you the margin of error, you can find that interval, confidence interval. Okay, let me go back. Are there any questions? Any questions about that? Now, this is just an introduction. You'll have to watch section 17 videos, but hopefully it's kind of easy what
I
we're
do
doing.
have a question. I think I know, I think I understand it, but just to verify, you're subtracting and adding from 51% of all
That's
people.
right.
Okay. All right. Just to make sure.
So,
Thank you.
yeah. So in this question, it tells me 51% of the people like the soundtrack. There's an inherent error there. It's 1.1%. They gave that to me. So I can add and subtract 1.1%. And
Right.
that's where I got 49.9 and 52.1.
Thank you.
Yep. And then, because if you have that question, I'm sure someone else does too. Same thing with this one, 82%. They tell me the error is 2.2%, so I'm adding and subtracting. That's where I got 79.8 and 84.2. Same thing with this one, 32%. I'm just adding and subtracting that error, 2.2%. Okay. All right. Yeah, any other questions? That was a great question. Are there any other questions about this? Well, no one's asked, but I'm going to tell you anyway. When I'm doing these examples, I'm skimming over that 95%. So I'm just kind of skimming over it. I didn't bring it up. I didn't mention it. I didn't need it to solve the problem. And what is that 95%? The 95% has to do with how this is getting calculated. And that's a little bit deeper than we need to go. But the textbook, for some reason, brings it up in the questions. So you can ignore it, but the 95% has to do with how confident we are with these results. Okay. And that has to do with the method we're using. But we're only teaching you one method in this class. So it seems weird, but it kind of has to do with statistics and probability and that kind of thing. So you can just think of it as the 95% confidence interval. That's how confident we are that these are the results. Okay. That's what it is. So to actually solve the problems, you don't need the 95% at all. Okay. And that's why I was skimming them while I was reading them out loud, because we don't really need it. All right. But it's there. So I want to present it as you'll see it. But it's just that we can say that we are 95% confident that moviegoers like the soundtrack from 49.9 to 52.1%. That's what we're saying. We're 95% confident. Okay. So in some ways, section 17 can be the easiest, and in some ways it can be the most complicated, depending on how deep you try to understand it. And the reason why that it's so confusing is because we barely teach it all. It's something we just throw in at the very end. Actually, even when it was earlier in the class, we just barely threw it in, and I just put it in there. But it's just to kind of get a feel for these polls or the real life polls that we see in the news every day. And they almost never actually, unless they're scientific or, a pretty hardcore paper, you never really see these confidence intervals anywhere, but they should be reported. Okay. So that's section 17. When we are done, well, I don't know, maybe we'll do it right now since we're talking about 17. I'll pull up the homework and just kind of point you towards what it's talking about. I will share my screen in just a moment. Okay, share screen. So this is section 17. What is the sample size? If the margin of error is 2.5%, I mean, this is the exact same, excuse me, this is the same question we just did, just with different numbers. So that should be fairly easy. This is just part 2 of that. This is the same question we just went over. So the questions we went over are very similar, okay? So I'm just introducing it tonight. Of course, you still have to read the textbook, and of course, you still have to watch those videos, but hopefully that will at least give you a kind of an introduction to the topic and a jump start to it, okay? So I'm going to get back and I'm going to start reviewing for the final exam. I thought about many different ways to review for the final exam, and the way I've ended up, what I decided to do was just work through one of the previous exams. So this is an exam that was given in the spring of 2020, and I thought that would probably just be the best way for you to see the difficulty level. And yeah, so this was given on a paper exam, and I thought this would probably be the best way for you to get a feel for what it's like. Okay. So we're just going to go through some problems. All right. So the population of Fort Wayne is 255,784 people. And the population of Indiana is 6,692,000. Use ratios to determine which of the following statement is not true. These are always the worst. Finding what is not true is always worse than finding what is true, because you have to cancel all three, three of these rather than just pick the one that's right. But this is how I would do this problem. So I took the population of Fort Wayne and I divided by the population of Indiana, and I found that it's roughly 3.8%. Okay. And then I just, swinging for the fences, I divided Indiana population divided by the Fort Wayne population and saw what that was. And that's 261%. So now I can kind of look at these options and decide what might be the best option. 38. So the first one, 38 out of every 1,000 people in Indiana live in Fort Wayne. Now, again, we're finding which one is not true. That's what the statement says, not finding which one is true, but finding which one is not true. That seems correct to me. 38 out of every 1,000 people would live in Fort Wayne based on this data. 26.1% of people in Indiana live in Fort Wayne. I do not think that's true. I think they got that from this calculation here, but that's not even a percentage itself. So that's not quite right. C, 1 out of every 26 people live in Fort Wayne. And then 33.8 people in Indiana live in Fort Wayne. So that's, I think it's true. So I think it has to be B that's incorrect, 26.1%. Now, always watch. If you ever see a math problem where it says which one is not true, those are always the worst. It's always better just to find the one that is true, because only one option is right. But, watch for that. So that's the first one. That was the first one on this test. Okay, number 2, there are 119 Walmart retail stores in the state of Michigan. The population of Michigan is 9.9 million. Which of the following best represents the store's per capita in scientific notation? So per capita means per person or per population. So that means we're going to divide. That's what I've done here. So I took the 119 Walmart stores divided by the population of Michigan. I found the results here. And to me, that would have to be number D. So we had to just move. Uh-oh, we got a question on number 1. How did I figure out this one? So I'm finding which one is not true. Which one is not true? I think B is not true because I don't think 26%, 26.1% of people in Indiana live in Fort Wayne. I think it's actually 3.8%. If I take Fort Wayne population divided by Indiana population, I get 3.8%. So I think B is incorrect. Does that make sense? Why I would say that? I mean, it is incorrect because it's 3.8%. So I just divided the populations. Fort Wayne divided by total population of Indiana.
Okay, that makes sense. Thank you.
Good, good, good. Thank you. All right, number 3. Number 3. Remember these guys where we did proportions? So if the number of college graduates in Indiana was proportional to the Michigan with respect to their population, how many college graduates would we expect there to be in Indiana? I remember the office hours, we were doing all kinds of problems like this. Proportional, okay. One of them, we're just gonna make the letter X. The other one, we have both of the information. So if the number of college graduates in Indiana, Indiana college graduates is what's going to be X. So I'm going to put an X right there. Okay, I know what the actual value is, but I'm going to say if it's proportional to Michigan, what would it be? All right, so I set up my proportion. There it is. Set it up. So I'm saying if college graduates of Indiana were proportional to Michigan, what would it be? After that, I just solve for X by multiplying both sides by the population of Indiana. And so that's what I got. I got 774,235. And I just pick which one is closest. And it looks like B is closest to me. All right. 17.4% of Indiana's population is school age 5 to 17 years old. If Indiana's population is 6.6 million, which value best represents the number of people that are school age? Well, I know that 17.4% of the population is school age. I know the total population, right? So 17.4% times 6.6 million. I got 1,148,400. I picked the one that's closest. Well, I think it's actually exact. It would be option D. So I just took the percentage of the total. And this would be a percent times base equals amount problem. But you're just taking a percentage of the total. Okay. Number 5, the following donations were collected by club members. And then we have a data set 21, 15, 17, 22, 23, 15, 16, 17, 35. What is the mean of the amount donated? Okay, so they're just asking what is the mean? The way we calculate mean by hand is we add up all of the numbers and then divide by how many numbers we added. For this, there was 9 of them. There's 9 numbers. So I added the 9 numbers up and then I divided by 9 because there's 9 of them. And I got 20.11 repeating. I picked the number that the option that best represents that. And that would be 20.11. That would be B. So I would pick B. Okay. All right. We did many problems like this. A student received the grades from a class with the weighted categories below. Which of the following best represents their final grade for the semester? So we got to calculate that final grade. How did we do it? We even did a project of this. We just take the grade times the weight plus the grades times the weight plus the grade times the weight plus the grade times the weight. So what would it be? So I did that there. Weight times grade plus weight times grade plus weight times grade plus weight times grade. I got 75.6, and that also looks like it's the letter B, so I would select that. Okay. All right. Steve's salary is $64,000 and Lori's is $52,500. What of the following statements is true? We got to pick which one is true. All right. Steve earns 22%. Oh, I didn't mean to spill the beans there. It's very difficult doing PowerPoint on Zoom. Steve earns 22% more than Lori. Steve earns 82% more than Lori. Lori earns 18% more than Steve. Steve earns 78% more than Lori. So this to me sounds like it's probably a relative change problem. So I have to determine what that is. So I did relative change going both way. Steve with reference to Lori, Lori with reference to Steve. And I find that Steve makes roughly 21.9% more than Lori, and Lori makes roughly 17.97% less than Steve. Now I got to pick which one is true. So is it Steve earns 22% more? Does Steve earn 82% more? Does Lori earn 18% more? No. Steve earns 78% more? No. I would say Steve earns 22% more than Lori. I would pick letter A. So this was a relative change problem. So that's how I would do it. A pizza parlor charges $12 for a plain pizza and charges 75 cents for each additional topping. Which of the following best models the cost of the pizza? Okay. So we have a base price of $12 and each topping we add is 75 cents. To me, this is our linear model that we learned about. This has got to be a linear model. All right. Now, out of the choices, I only see that B and C are a linear model. Those are only, well, I guess that's not true. B, C, and D are linear models, but B and C are the only things that could even possibly be true. Now, if we let X be the number of toppings, it has to be B. All right. Having X attached to the 12, that would be number of pizzas with one topping. So that wouldn't make sense. So $12 for the base plus 75 cents for each additional topping. This would have to be the line y equals 0.75x plus 12. So I would pick B. All right, number 9. $45,000 motorcycle value decreases at a rate of 12% per year. Which of the following models the value of the motorcycle after 2 years? Okay, in the previous problem, the pizza's value went up each topping you added. It went up by 75 cents. this motorcycle is decreasing by a percentage. When you decrease by a percentage, that is an exponential either decay or increase. This is decaying. This is decaying by 12% per year. Okay. So this decreases by a percentage per year. If you decrease by a percentage, that's the exponential. If you decrease by an amount, that's linear. So it's 45,000 is the starting value, 1 minus 0.12, because it's decreasing 12% each year, and T stands for years. So I would have to pick that letter D would be the best option. Okay, I know a lot of you are going to be tempted to pick B in this one, and that's not true. I've seen that in your work before. This cannot be true, because if we put 12%, that's decreasing 88% each time. We want to decrease 12% each time. Okay, so be sure that that makes sense to you. So that's where the 1 minus 0.12 comes from. All right, here is the credit card problem. Your friend carries over $250 on his credit card, which has an APR of 18.99. Which of the following best represents the finance charge for this month? Well, you guys are finance charge experts at this point. How do we do it? You take the APR, you divide it by 12, and you multiply it by the balance. There we go. So about $4, right? In this problem, it looks like B would be the best option. Okay. Your friend is currently paying $575 in rent monthly and wants to know how much she could borrow using a 30-year mortgage at 3.5 APR for the same payment as her current rent. What could you type into Excel to calculate this value? All right, what are we even trying to calculate? So friend is paying $575 in rent monthly and wants to know how much she could borrow for a 30-year mortgage. Okay, so we're trying to figure out the loan. How much is the loan? Not the payments. We know what the payments are. We're looking for the max loan. If we want the loan, as you guys know from your projects, I can tell, we have to use the PV function. So for this, I know it's the PV function. So really, I can throw out all of the other options because I know it has to be the PV function. And only one of these even has that. You can check. Yeah, it's 3.5 APR divided by 12. 30-year times 12, that's the number of payments. And we have to put that minus sign because we're paying 575. Yep, it's got to be D. But I'm sure all of this is fresh because you just turned in your project, so that should be no trouble. Okay. Number 12. This one is, and the one on the actual final exam is different, but the idea is the same. 26,000 deciliters is how many kiloliters? Now, this is just a conversion in the metric system. So you have to convert in the metric system on your final exam. This isn't the actual same problem. It's not deciliters, but converting in the decimals or in the metric system is easy if you know what to do. So my suggestion is always to go to the base. So here we're talking about liters. So take deciliters to liters and liters to kiloliters. That's always going to be my suggestion. If you're dealing with centimeters to kilometers, I would do the same thing. If you're dealing with anything in the metric system, that's how I would do it. That's my advice to you. So that's what I did here. 26,000 deciliters. That's 10 deciliters per 1 liter. And there's 1,000 liters in 1 kiloliter. So this would only be 2.6. So you're only moving the decimal place. As you can see, we're only moving the decimal place. But with these conversions, you have to know how many times you're going to move that decimal place. Okay. All right. You determine that you need a 16 square feet of contact paper to cover the top of the table, but the store needs the measurement in square inches. Choose the value that is closest to your needs. So we have 16 square feet. We're trying to get to inches, square inches. We need to convert, but because this is squared, we have to convert twice. So I have to convert to inches twice because I'm in feet squared, which means I'm going to have to multiply by 12 times 12, which is 144. So 16 times 144 is 2,304. I picked the option that represents that best. That would be option B. Okay. So remember, with these squared units, you have to convert it more. You have to convert it twice. If it's cubed, you have to convert it 3 times. Okay. There will be a problem like this on your exam. It's not the same. It's a different story. It's a different unit, but the idea is the exact same. If you have units that are squared or cubed, you have to do it either 2 times or 3 times, depending on the specific problem. Okay. All right. Number 14. Men's shoes follow a normal distribution with a mean of 10 and a standard deviation of 1.5. If a store owner wants to stock shoes that fit the middle 99.7% of men, what sizes should she order? So this is normal distribution. We have the mean, we have the standard deviation. I would say the best thing to do is fill out the curve and find where we are. So that's what I'm going to do now. So I have my curve here. Now I'm going to fill it in with my values. So I have a mean of 10. That's going to be that fancy U at the bottom there. I'll replace that with a 10, and then I'll either add 1.5 or subtract 1.5, depending on which direction I'm going. There we are. Now we want values for the middle 99.7%. Well, that's 3 standard deviations. So that's going to be that 5.5 to 14.5. So all the values you see in the bottom there. Okay. So I just filled out the normal curve. All right, 15. The weighted boxes of candy are normally distributed with a mean of 18 ounces and a standard deviation of 2 ounces. Random box is chosen for testing and weighs 13 ounces. What is the z-score for the box? So we're given the mean, standard deviation, and the value. We want to find the z-score. We have to use that formula. So z equals the value minus the mean divided by standard deviation. So in this problem, the value is 13, the mean is 18, and the standard deviation is 2. So I divide by 2. I got negative 2.5. So I think the z-score would be negative 2.5. I think the answer would be C. We actually don't need the probability for this, but I put the table here just in case, just so we could talk about it. But this would be the corresponding probability of that occurring. But if we just want the z-score, that would be option C. All right. Number 16, what is it called when you get a negative test result for the disease that you do not have? So this is the new stuff, and it will be on the test, but this is the new stuff where we have that chart which has all the false positives, false negatives, true positive, true negatives on there. And for this question, what is it called when you get a negative test when you don't have the disease? Well, a negative test is going to be a negative. So we know that this is either A or D. and you don't have the disease and you tested negative, well, that's true. You don't actually have the disease, so that's true. So this would be a true negative. This would be option D. All right, this one's kind of involved, but let's go through it. So Professor Ivy wants to buy a rain barrel that and has two choices: a rectangular container that has 2 feet by 2 feet by 30 inches tall, or a cylindrical barrel that has 0.3 meter radius and is 1.1 meters deep. Determine the volume of the cylindrical container. So here we have to go back to our formula of what was a cylinder. I've provided that here. I even provided a picture for you. So the volume for a cylinder is the area of a circle times the height of the cylinder. Now, this particular one is 0.3 meters, and it is 1.1 meters tall, and we have to multiply it times pi because of the area of a circle. Okay, so this is pi times 0.3 squared, or 0.3 times 0.3 times 0.1, and I get this awkward looking number here, and I'm gonna not round it too much, but because I needed it for a future problem, but this is what I think the volume is in meters cubed. Now in office hours, I can't remember if it was last time or 2 times ago, I think it was Grace that asked me, can we use the pi button on our calculator, or do we use 3.14 for pi? And there is one problem on the final exam which requires you to use pi, and you can use either value and it will count it correctly. So you can either use the pi button on your calculator, or you can use 3.14. It will count it correctly, both of them. Okay. So can't go wrong. Can't go wrong. Okay. All right. Continue with this problem. Determine the volume of a rectangular container. So rectangular container, we have 2 feet by 2 feet by 30 inches tall. So here's my little box, and that's length times width times height. And this is 2 feet by 2 feet by 30 inches tall. Well, they're kind of mean because they gave me 2 different units. They gave me inches and feet. So I have to convert the inches into feet. So that would be 30 over 12. So that'd be 2.5 feet. And then now I can just multiply the 3 of those together and I get 10 feet cubed. Okay. Not so bad. Which one has the larger volume? And this is kind of mean because they're in 2 different unit systems. One's imperial and one's metric, which means we're going to have to convert one of them to the other to compare. So that's what I've done here. I converted this to feet cubed. The other way you could do it is go feet cubed to meters if you want to go the other way. But I converted this so I could see which one was larger. And I found that the cylinder was larger, but I had to convert them into the same units to be able to do that. Okay, that's probably one of the most, I mean, it's certainly one of the most involved questions on this exam. There is a similar question on your exam, okay? And you will need to either use 3.14 for pi or the pi button. You can use either. Okay, let's keep going. You have a choice of 2 cars to borrow for a 120-mile trip. An all-electric car that requires 5 hours of plug-in time at 7,200 watt charger before the trip, or a gas hybrid model that only needs gasoline and has fuel efficiency of 45 miles per gallon. Calculate the CO2 emissions that would result in charging the electric car for the trip. So we have two different cars. One's all electric, the other one uses gasoline. And we're going to see the CO2 emissions of both. The first one's asking about the electric car. So the electric car charges at 5 hours for 5 hours at 7,200 watts. For that, I have to convert to kilowatt hours. So I have 5 hours times 7,200 watts, convert that to kilowatts, and then I can use my yellow sheet to convert to pounds of CO2, 1.37 pounds of CO2. I got roughly 49.32 pounds of CO2 for the electric car. Part B asks to calculate the CO2 emissions will result in driving the hybrid car. Now this is 45 miles per gallon. And I think we were told how many miles, 120 mile trip. So we can convert this 120 mile, 1 gallon of gasoline for every 45 miles. And the consumption of gasoline is 19.8 pounds of CO2 per gallon. So this would be about 52.8 pounds of CO2 produced. So a little bit more, not a crazy amount more, but a little bit more. And then C is a very, very open-ended question. And it says, explain which car would be more environmentally friendly in terms of CO2 production. Well, in terms of CO2 production, as far as this, I would say that the electric car does technically win. It is a little bit better as far as this goes. Of course, the production of those batteries and everything, but so it is a little bit better. So the electric car has fewer pounds of carbon dioxide produced. Okay. So you'll have something like that in your final exam. Okay, here's the type of questions everybody hated. That was the dosage questions. So we're going to give a puppy some medicine here. Your friend is fostering a newborn puppy, and the formula bottle instructions state that it's 10 milliliters per kilogram per day to be given 3 times per day every 8 hours. If the puppy weighs 4 pounds, what is the individual dose that it would receive every 8 hours? Round to the nearest whole number. Okay. If you ever get a question with medicine and they give you the pounds or how much the patient weighs, whether it be a puppy or a person, always start with the pounds. Always start with the pounds. Okay. So in this problem, we're going to go from pounds to milliliters. Okay. How would I do that? Start with pounds, convert that to kilograms. Then we can convert kilograms to milliliters as given by the problem. And then we have to divide by 3 because we're giving 3 doses a day, 8 hours, 24 hours in the day, so 3 times. So roughly 6.048 milliliters per dose. Okay. So if you have a question, just like in the homework, if you have a question where you are faced and they give you the weight of the patient in pounds, that's the value you start with and work your way forward. Okay. All right, number 20. An ant traveled 18.9 miles per year. How fast is the ant moving in meters per day? So this is just a conversion problem. we're given miles per year, and we want to go to meters per day. Well, the lengths are in different systems. Miles is the imperial, and meters is the metric system. So we have to convert that. And then years to day, well, there's 365 days in a year, so we can convert that pretty easily. So I start with what's given, 18.9 miles per year. I can convert that to kilometers using my yellow sheet. Then I can go kilometers to meters, and then I can go years to days. So I found 83.33 meters per day, given the information in this problem. Okay. So I just use the information from the yellow sheet. All right. There is a problem very similar to this on your, or at least the first part on your final exam. The graph below shows information about ages of nurses with advanced licenses in Indiana. How is the data in the graph distributed? Symmetrically, skewed left, and skewed right. Okay. You will have a question like this on your test. Now, if you can go back and look when we talked about this, but the quickest way to remember is that if most of the data is shifted in one direction or the other, it's skewed the opposite way. Okay. So if I look at this, I would say most of the data seems to be on the left side. To me, it looks like I would want to say, well, the data is skewed to the left, right? Because most of the data is occurring to the left. If I look at 65 and older, it's very short. If I look at under 35, it's quite tall. So it's actually the opposite. So if the data looks like it's pushing towards the left, that it's actually skewed right. And that has to do with how we defined it, which was if the mean was greater than the median or the median was greater than the mean. That's how we defined it. But visually, it's the opposite. Okay. So I would say that this data is skewed right, just looking at it, because most of the data is pushed to the left. So that means the mean would be greater than the median, the middle number. So I would say skewed right. So remember that when you take your test, okay? When you're looking at the data, it's the opposite of what you would think, all right? All right. Part B, approximate the total number of nurses from the survey using the graph. So the way I did this was I just looked at the graph and the numbers that are given. So under 35, looks like it's 1,200, 35 to 44, 1,600, 45 to 54, 1,200, 55 to 64, 1,000, and 65 and older, it looks like it's about 200, given the information in this graph. So I would just add those together, and that's what I did. So it'd be approximately 5,200 nurses. Okay. Just adding those together, right? Nothing too crazy. Estimate the probability that a nurse selected at random from the survey is 65 and older in the group. The 65 and older was 200 nurses over the 5,200. So I got roughly 3.8%. Okay. All right. Car website tracks the prices of cars and finds that the price of a new sedan follows a normal distribution with a mean of 24,200 and a standard deviation of $800. Use the mean and standard deviation to fill the numerical values of the normal curve. Okay, so here, and on your test, you will have to fill out those values. there's just spots at the bottom for you to fill it out, since you're taking it online instead of in person. But there will be blank boxes for you to type in the numbers. So for this one, it's the mean of 24,200 and the standard deviation of 800. So I'm going to add or subtract depending on which way I go. So there I filled it out for myself. And so that is complete. I have filled out the values. Part B, sedans that are listed more than $25,000 are labeled as overpriced by the website. What percent of sedans would they expect to be listed as overpriced? So over $25,000 are overpriced. What percentage are over $25,000? Since this is normally distributed, we can just add those percentages together. We have 13.5, 2.35, and 0.15. We can just simply add those three together, since those are the three percentages that are greater than $25,000, and that would equal 16%. So 16% would be overpriced. Sedans listed as $21,800 are or less are labeled as a super deal. How many sedans out of the 2,000 listed would you expect to be a super deal? Show how you arrive to your value. So we want to go less than 21,800. That is the first value on our normal distribution curve. So that would only be 0.15%, which would be less. If I multiply by that, the given 2,000, that would only be 3 cars, which would be super deals. So not terribly likely. Not terribly likely that we would get one. Okay. Question 23, 1-year-old baby boy weights have a mean of 23 pounds. I don't have no idea if this is factual or not, but this was an actual exam. So 1-year-old baby boys weights have a mean of 23 pounds, has a standard deviation of 3 pounds. If Dom weighs 19.4% or 19.4 pounds at his 1-year checkup, what is the z-score for his weight? So, okay, we have the mean, we have the standard deviation, and then we have Dom's weight. So that would be the value. I would plug that in my formula. So 19.4 pounds minus the mean, which was 23 pounds, divided by the standard deviation. I got negative 1.2 as the z-score. For part B, what percentile would this weight be in? Well, I could check my table. It's on the yellow sheet. It's on the backside, page 236, or I think it's 195. It's also in the book. It's in the book twice. But I checked the table. I get 0.1151. So this would be, if I rounded it, the 12th percentile. Dom would be in the 12th percentile. So Dom's parents have never heard of the term percentile. How would you explain what this means for their child to be in this percentile? Well, 12th percentile means that only 12% of children at this age would weigh less than Dom. So Dom is actually kind of small with this information. Dom only weighs as much as or more than 12% of the boys. Okay. So remember that our probabilities go from 0 to that value. So that's always confusing, but it goes from 0 to that value. All right. Next few questions have to do with probability from a chart. So use the table provided. Any Ivy Tech campus completed a study tracking the semester of students that will finish their degree, whether they intend to participate in the graduation ceremony or not. The table below shows the result. So we're given a table. of Ivy Tech students graduating. They either will attend graduation or will not attend graduation. And we're going to answer questions about it. Part A, what is the probability that a student chosen at random from a study completed the degree in spring? So random student, what's the probability that they get completed their degree in spring? I would take all of the students that graduated in spring and divide it by all of the students. So 380 divided by 1,000 is 38%. What is the probability that a student chosen at random from the study finished their degree in the summer and will attend graduation? So this is two things. Finish their degree in summer and will attend graduation. So it has to be both of them. Summer and attend graduation. Looks like there's 24 students. So that'd be 24 out of 1,000. That'd be 2.4%. Part C, what is the probability that a student chosen at random from a study finish their degree in the fall or will not attend graduation? Or is one of those tricky words because that means one or the other or both. So this is fall or will not attend. We have to count both of them. So that'd be all of the students that graduate in fall, all of the students that don't attend graduation. We have to count all of those students. So that's what I did here. And what I did was I just subtracted how they overlap, what they overlapped, the ones that did both. So I just added all the fall, all that will not attend, and then I just subtracted the ones that overlap so I don't overcount. And I got 72.2%. So or is a little tricky. Part D, based on the study, if a student chosen at random will not attend the graduation, so we're guaranteed they're not going to attend the graduation, what is the probability that he or she finished the degree in summer? So because they told me this student is not going to attend graduation, we only need to divide by students that are not going to attend graduation. So that'd be 620. What is the probability that they go in the summer? That would be 86. 86 over 620 would be 13.9%. Okay, now this is the new stuff. I'm sure many of you are still working on this, but this will be practice. All of the problems are roughly the same. You just got to get the system down. I don't know if you guys are struggling or not, but we have a few of these on the test, so be sure you can do it. I say we have a few. We either have one or two. There's definitely one on there. I can't remember if there's one or two. Well, let's do this one. A new test has an 84% accuracy rate, early identification of strokes. A study uses a new test on 1,000 patients. 30% of the participants actually had a stroke. Fill out the table for 1,000 subjects. So the first thing to do with these tables is to fill out that the most right column there. So they told us that 30% of the participants had a stroke. So 30% of 1,000 would go in that top right box, and then 70% would go when he does not have a stroke. Okay, so that's what I would do there. So I calculated that first. Now, our test is only 84% accurate. So for the top row there, they actually had a stroke. It's only going to test positive 84% of the time. And these people actually had it. So 84% would actually test positive. 16% would test negative because of our test. we got those values. Now for the next row of 700 people, it's only 84% accurate. So 84% will test negative and 16% will test positive. And then for the totals, I'll just add the numbers together. Okay. So if you're still, if you're still practicing putting these tables together, because the homework isn't due until tonight, I understand, but hopefully this will give you a little bit more practice in seeing how we do that. Now we have to answer some questions. If a patient receives a positive test, what are the chances he does not have a stroke? So out of those that received a positive test, that's 364 for this chart. How many did not have a stroke? That'd be 112. So 112 divided by 364 is roughly 30.8%. But most of it comes from, filling out that chart, obviously. And there is a chart like this on the test. So be sure you can do it before you take the test. Number 26, the following is an excerpt from the Pew Research Center ongoing study. The Pew Research Center surveyed 979 technology experts and found that despite the downsides of artificial intelligence they fear, 63% of respondents said they are hopeful that most individuals will be mostly better off in the year 2030, and 37% said they will not be better off. What is the population represented here? Well, this is kind of unfair that we're going over this because you haven't done section 17 yet, but this is one of the examples on the test. So I'll just give you the answer. The answer here is technology experts. That will make more sense once you go over section 17. But what is the population represented here? That would be technology experts. It's like kind of like asking you who was asked here, who was polled. What is the sample size? Well, we did some of those questions earlier tonight, so maybe it makes sense. But 979 people were asked, right? So that would be the sample size. If the margin of error is stated to be 1.4%, calculate the confidence interval of that will not be better off. Not be better off is 37%. So 37% minus 1.4, 37 plus 1.4 gives us our interval. Okay, that will make more sense once you do the section 17 homework, hopefully. But we saw a few of those examples earlier tonight. Express your answer in a meaningful sentence. Again, this is going to make more sense after you do the homework. We can say with 95% confidence that 35.6% to 38.4% of all technology experts believe that individuals will not be better off in the year 2030 due to artificial intelligence. Okay. So what is due? Homework section 17 is due on Sunday, and then the final exam, the exam 3 module is due Tuesday, 11:59 Eastern Standard Time. No extensions can be given. And this is the end. Okay. So for your real exam, which is 29 questions, you have 3 hours to do it. Okay. Now, I know I went fast, but I have to go fast because I'm trying to do 2 weeks worth of material in 2 hours. So I have to go kind of fast. Normally, we would have done that in the course of normally a normal class that doesn't exist anymore met for 6 hours a week. So we meet for 2 I'm gonna go twice as fast. So we're going kind of fast. The good thing is that's all recorded, and I'm gonna upload the presentation slides if you want to flip through it. And you have practice tests with the answers, and you have a test review that you can take infinite amount of times until you get the grade you want. So I think you have everything you need. For the final or for the exam, you can use your physical textbook. I would have the yellow sheet ready. Need it because you're going to need those conversion factors, and you might need this table on the back. So you might need those things. So have that ready. To the textbook as you please. You can have paper notes as you want. You can have anything on paper you want, but you can't use your phone while you're on the test, okay? Or another computer or anything like that. That's the only stipulation. Okay, we're going to use lockdown browser. I'll have office hours on Sunday. To answer any questions you might have on section 17 or while you're studying for the exam. And then I'll have office hours on Tuesday, but I bet nobody shows up, but I'll have them anyway, just in case there's any last minute study questions once you're studying for the test. If you have any questions, that kind of thing. Let's see. Are there any questions? I'll show this one more time. So module 8 has to do with completing homework section 17. You have the textbook solutions, the videos. Practice test is completely optional and up to you whether or not you want to use them. There's 3 paper exams with the answers right here. You do not have to do those if you do not want to. That's up to you. And then exam 3 itself, you have the test review, academic honest policy, basically don't cheat. And then the actual exam, 100 points. That's the due date. 29 questions, 180 minutes. Yeah. So it is comprehensive. But yeah, you should have all of the necessary tools to do well. Okay. Any questions? Yeah. Okay. Yeah, so I will stick around for homework questions. I'm going to stop the recording if it's just homework questions, I'll stop the recording, but that's the presented materials. Okay.